Hey, welcome to the channel, or welcome back if you've been here before. Today we're going to take a look at a new mid-range power station from a company called Dabbsson. But right up front, I do want to point out that while I have checked that little box that shows that paid promotion banner that you're probably seeing up there in the upper left-hand corner, and I did that because Dabbsson did send me this review unit for the video, but they are not paying me to produce this video, and they do not have any editorial control over the opinions that I'm expressing in the video. All right, so with that out of the way, you might be thinking, who are these Dabbsson guys anyway, and why haven't I heard of them? And yeah, Dabbsson doesn't currently have the brand recognition of, say, a Jackery or Blue Eddy or EcoFlow, but I have reviewed several of their DBS series power stations over the past couple of years, and I can tell you that those Dabbsson units have not only been some of the best built power stations that I've had my hands on, but also the Dabbsson mobile app is arguably the best power station app on the market, with advanced features that only maybe one or two other brands are just now starting to catch up to, and then many other features that pretty much no one else is really doing yet. So I'll show you what I mean by all that in a bit when we take a closer look at the mobile app, because these are features that I think are actually quite practical and useful, and not just kind of like, you know, hey, we added these just because we could kind of features that nobody uses. But these are things I think a lot of you are going to appreciate. All right, so in addition to Dabbsson's DBS series of power stations that I just referred to, and those are mostly focused on things that like expandability for capacity and home power backup solutions and things like that. They're now offering their L series of power stations, which are more focused on portability. And so from what I can tell, the L series power stations don't offer things like capacity expansion options, but they're also surprisingly affordable. And I'll discuss pricing later, but I think you're going to like what you hear. And despite that very competitive pricing, this L series of power stations still seem to offer that very good Dabbsson build quality and that mobile app functionality that I saw in the DBS series. So today we're going to take a close look at this guy right here. This is the Dabbsson 2000L. It's got an AC inverter rated for 2200 watts of continuous output with a peak surge of 4400 watts through these 6 AC outlets on the front. It's got a rated battery capacity of 2048 watt hours, and it's using semi-solid state lithium iron phosphate battery cells, which is currently one of the safest battery chemistry options available. And those cells, by the way, are rated for a full 4,000 cycles, after which they should still retain at least 80% of their original capacity. Now you can charge this 2000L via AC at up to 1500 watts or with up to 800 watts of solar, and I'll get into the details of that a little bit later. But it will also allow you to dual charge with AC and solar at the same time, but that is still capped at 1500 watts. Now it's got a couple of older style 15 watt type A USB ports, and then it's got a 30 watt and a 100 watt PD100 type C port, which is pretty handy for fast charging laptops and tablets. And it does have the typical 12 volt 10 amp auxiliary car socket, and it's even got a 40 watt DC 5521 barrel connector port on the front. It supports a 15 millisecond UPS mode, which Dabbsson calls EPS mode in order to differentiate it from the sort of 0 millisecond UPS devices in the more commercial grade category. But 15 milliseconds is still plenty of fast for people trying to keep their CPAP machines, their home routers and computers and refrigerators running in a power outage. It weighs in at a very manageable 41 pounds and has a surprisingly compact footprint at just 8.8 inches wide, about 11.2 inches tall, and about 18.3 inches deep in this direction. And it does come with a 5-year warranty. Okay, I think that covers all the important specs, so let's go put this guy through the paces and see how it actually performs. All right, as you can see, I've got this 2000L fully recharged, and we're doing a DC discharge capacity test to find out how many usable watt hours out of that rated 2048 we can get out of this DC aux car port here. Now we are pulling 10 amps. I'm currently showing under load 11.27 volts. And we'll check back after the BMS shuts us down. We'll find out how many watt hours we actually get. All right, looks like our DC discharge capacity test is done. Let me just make sure we're at 0% state of charge. And we are. So let me zoom in here so you can get a better look. All right, as you can see, we got 1,694.9 watt hours. And that equates to a very respectable 82.7% of rated capacity out of that DC output port. So yeah, that is a pretty solid number of DC usable capacity. So let me get this thing charged back up, and we're going to see how many usable watt hours we can get out of the AC inverter. All right, we are fully charged back up on this Dabbsson 2000L. Let's do an AC discharge capacity test and find out how much usable capacity we can get out of the AC inverter. And while we're at it, we'll also see how much voltage this thing is actually putting out. So let me turn the AC inverter on. which is down here. All right, just heard the inverter relay, so we should have power. Check the voltage, and we are at pretty much 120 volts right on the dot. So that's outstanding. I always like to see a full 120 volts. And we've got kilowatt hours actually completely reset. Now this is a 2200 watt continuous rated inverter with a peak surge rating of 4400 watts. So if we're going to do, or at least try to do, a 0.2C discharge rate, or 20% of the inverter capacity, that would equate to 440 watts. Now, it's going to be kind of tricky to get it right at 440 watts, so I might have to play with this a little bit and see if I can find the best mix between 400 and 500 watts. So let me go ahead and add a load here. Let's see where we are right now. So we're at 512 watts. Let me drop that just a little bit. All right, so 400 and call it 12 watts. So that's pretty close to that 440 watt mark. So let's let this 2000L run all the way down until the BMS cuts off the discharge, and we'll see how many watt hours we actually collect. All right, our AC discharge test just completed, and it is at 0% state of charge. So let me go ahead and plug the watt meter into grid power and see how we did. So the test ran for 4 hours exactly, and we got a very good number. So 1,900 watt hours, or 1.9 kilowatt hours. So that's out of that rated 2048, which is a well above average 92.7% of rated capacity. So very good usable capacity numbers through this AC inverter. Now I'm very interested to see what the idle consumption is on this inverter, because it seems like it's pretty efficient. But yeah, definitely nothing to complain about in terms of usable capacity through that AC inverter. All right, since we are fully depleted, let's go ahead and do the solar wake and charge on this 2000L and find out if it will wake and charge on its own when solar input becomes available in the morning. So it has a 800 watt max solar input, and of course you can overpanel that if you want, up to a max voltage range, working voltage range of 60 volts. And it does have a 20 amp cap. Now I believe the actual max voltage is 75 volts, but in terms of planning, you shouldn't actually try to put more than 60 volts into it. So I've got a 450 watt solar panel that I have wired here into my shop, and we are going to plug this in to the XT60 connector in the back. And that 450 watt panel, I believe, has a volts open circuit of somewhere around 38 or 39 volts, so well under that 60 volt cap. Now it's 10:30 at night, so we're obviously not going to get any solar whatsoever. Let me go ahead and plug that in, and I doubt that it's even going to detect a connection. Yeah, so we're just going to let that sit. It'll shut itself off here in a bit. It will check back in the morning and find out if this thing is going to wake and charge on its own or not. All right, it is about 10:30 a.m. and we have partly cloudy but mostly sunny skies. And I see a little breathing light here on the power button. Let's see what it's doing. That is a good sign. So it shows we're currently pulling in 318 watts, and that is with the sun still not fully aligned. And as you recall, I have a 450 watt portable solar panel connected to this right now. We're already up to 19%. So wake and charge test is a definite pass on this 2000L. So I'm going to let this thing continue to charge throughout the day, and let's just see how much state of charge we can get out of this in a typical day of decent sun on this 2000L with a 450 watt solar panel. All right, while we're charging this 2000L via solar today, let's go ahead and do the AC inverter noise test. There's no reason why we can't do that while we're charging. And I'm going to use my old guitar amp. And what we're going to find out is whether or not, if you wanted to use this for something like powering guitar amps, PA systems, ham radios, whether or not the AC output from this inverter on the 2000L is relatively clean or relatively noisy. This definitely will reveal what the case is here with this old guitar amp with no noise suppression on it. I've currently got it plugged into grid power here. Let's get a baseline sound sample of what it sounds like running on clean grid power. All right, relatively quiet. You will have heard a little bit more noise than what I just heard because I will have boosted that volume for you so you can hear it clearly. All right, now we've got the amp plugged into the 2000L. Let's turn the AC inverter on. Wait for the relay. There we go. All right, let's do the same test with the AC inverter from the 2000L. Interesting. Okay, so that is a little bit more noise than I would be comfortable with. I'm kind of curious if this makes a difference if I move this further away. So let's just try that. I'm hearing still some noticeable buzz, but it is less. So just something to be aware of. That may not be the best use case for this 2000L, but if you wanted to use a line conditioner, that would certainly eliminate the problem if you already have one of those, and a lot of musicians do. So just something to be aware of. All right, it's a little after 5 p.m. and sometime in the last, I don't know, 90 minutes or so, we topped out at 100%. So yeah, today's weather was mostly sunny with some high cirrus clouds wisping here and there. So there were some times when we got a little bit, little cloudy, but temporarily. But I just kind of want to point that out, give you a sense of what you could do with a 450 watt panel and a power station that's got just a little over 2,000 watt hours of capacity. So definitely enough solar input to be able to top this thing off in a full day of sun. And if you were to max this thing out at that full 800 watts, well, you could get it topped off in less than a half a day of solid sun conditions or in a full day of less than ideal conditions. So, you know, there's that. So excellent solar performance on this 2000L. All right, let's do some load testing on this 2000L. Now it's got a 2200 watt rated inverter on it. So 2200 watts continuous with a 4400 watt surge rating. We're currently servicing a load here of 1682 watts. And I've got my watt meter up here on the volt page so we can see how much voltage we're outputting and whether or not we're seeing any significant voltage drop. So right now we're just under 120 volts, so no real significant voltage drop to speak of. So let me add another load and let's see if we can get this up to 2200 watts or very close to it, maybe a little bit over. And then we'll see if it'll run that load for a full 10 minutes. All right, so we are at 2100 watts. Let me take it up another 100. And we're just kind of keeping our eye on that guy right there. So there we are at right at 2200 watts. So let's go ahead and start the timer. All right, no problem with the 10-minute load test at full load. We're still pushing 2200 watts. And when I'm not talking, we're at about 55 decibels. So this thing has actually got a nice soothing neutral white noise. And if you're basically, you know, a meter away or more, a yard away, the decibels drop to below 50, which I would call this a relatively quiet machine. It's not silent, but it is pretty quiet, certainly quiet enough for me. So let's find out if we push this thing, what we can get away with. Let me go ahead and get the screen back on so we can see we're still at the full 119, almost 120 volts. So that's excellent. Let's see what we can do to trip this now that this has been running for over 10 minutes full out. So let me take it up another 100 watts and we'll see what we can get away with. And when I do that, we'll start a timer here. And we'll just sort of keep an eye on how much time we can get away with overloading this. So we are at 2292, so almost 100 watts. We are still holding steady at 120 volts. All right, so we're coming up on a full minute at 100 watts over that rated 2200. So let's see if we take it up another 100 watts, if we can continue to operate. This is already very impressive. So we are coming up on just almost 2400 watts, so 200 watts over the rated output. And our voltage, by the way, is still holding steady, 119.5 volts. This is very good performance. 2400 watts. All right, coming up on 2 minutes at 200 watts over rated. Let's take it up another 100 watts. I gotta believe we're gonna trip here shortly. All right, we are at 2483. Now we've dropped voltage. Voltage is suddenly being throttled. So that's why we're seeing kind of a little bit of variation here. All right, so we know we're gonna get throttled. This is not a voltage range you wanna be running complex electronics with. So TVs, computers, refrigerators, those kinds of things are not going to be happy at 104 volts. It's not really good to run those. Purely resistive loads like heaters and lights, typically no problem, even if you were to drop this kind of voltage. So we are voltage throttling, and it's kind of holding us to just under 2300 watts. So I'm kind of curious. I'm actually going to throw another 200 watts at it, which would give us about a 2600 watt load. And it's got a trip here soon, I would imagine. So we've already got stuff cutting out here. We're back to 120 volts, but our voltage is going to continue to fluctuate. Our output is going to fluctuate as I have power stations that are not happy with low voltage dropping out. I just want to see where we can get it to trip. We're actually showing 2700 watts right now. Add another 200 watts. 2900 watts. This is a full 700 watts overrated, and we're dropping voltage again, which is going to cause our output to drop as well. And it's going to try holding us again to around 2200 watts. Now I do have my power station loads that I'm trying to charge with this dropping out because of the low voltage, and we're climbing back up. So we're kind of in this limbo state where it's just going to keep behaving like this. Let me add another couple hundred watts and just see if we can get this thing to actually trip, or if we are going to just continue to bottom out on the voltage. So we're at 3100 watts. Voltage just got dropped. I heard a power station cut out, and now we're at 0% or zero output, and it's going to keep trying to climb. Okay, so let me stop torturing this thing. Go ahead and shut off the AC output. All right, so the inverter load test is a definite pass. You can absolutely sustain 2200 watts and then some. In fact, you could probably get away with just a little bit more, or maybe 2300 watts. But once you get around that just below 2400 watt range, it will start cycling the voltage throttling on you, and it will then try to regulate your power max at just around 2200 watts. Actually, slightly above that. I think we were around 2280 watts. But yeah, so that's how that's going to behave. And like I said, you don't want to run complex electronics when it is voltage throttling. So make sure that if you're powering things like TVs and computers and air conditioners, for example, those things, you want to make sure you're staying below that 2200 watt continuous load output to avoid the voltage throttling. And you will get the nice full 120 volts when you do that. So very good load performance on this inverter. All right, time to do the power tool test with this 2000NL. We're going to try 3 power tools covering a fairly broad spectrum of inrush current. So first we've got a 3 horsepower, 8 gallon shop vac, and it has an inrush current of just about 27 amps. So let's see if that will run, and we're going to kind of watch the voltage here to see if there's anything weird going on with voltage as we kick this thing on. So let's try the shop vac first. 27 amps approximately on the inrush current. All right, no problem at all with the 3 horsepower shop vac. I didn't really even see any movement on voltage whatsoever. So now let's try the 10-inch Ryobi table saw. Now this guy has an inrush current of about 52 amps, so 51.7 amps, something like that. So we'll round it up to 52, and we'll see if this thing can handle that. Here we go. All right, so 10-inch table saw, definite pass. I did see a little movement on the voltage, but I'll have to zoom in there and see. Hopefully I've already done that for you so you can see what's going on there. All right, now let's try the big guy. This is just shy of 65 amps of inrush current on the 12-inch Hercules miter saw. So this is usually the guy that either fails or passes, and usually everything else in the 2000 watt range can handle what we've tried so far. So this is going to be the big test. So let's give this a try. Again, just shy of 65 amps of inrush current. All right, I did catch a glimpse of a dip down to 106 volts, and then it immediately popped back up to the full 120. So it did handle the 12-inch miter saw without a problem. So power tool test is a pass on this 2000L. All right, so let's wrap up with some final observations. Now, I did test the idle consumption on both the AC and DC sides, basically telling us how much power this thing will use just by energizing either the AC or DC outputs without any loads connected. And the AC inverter will consume about 1% of the overall battery capacity per hour that you leave it on. That calculates out to about 20 watts, which is fairly average. And on the DC side, if you leave those DC outputs enabled, those will consume about 0.6% of the total battery capacity, or about 12 watts. Now you might be thinking, now why is there any loss at all on the DC side? Because there's obviously no inverter involved. Well, that's certainly true. The battery pack voltage on a power station in this particular class is usually somewhere between 30 and 50 volts. And so to output at 12 volts DC, you have to step that voltage down. And so you need a step down converter in there to do that. And so that's why there's going to be some loss just by leaving those DC outputs turned on. And that's also typically why you want to take advantage of the energy saving modes in the mobile app that will automatically turn off those AC and DC outputs under specific conditions that you define. And speaking of the mobile app, you'll recall from my intro comments that Dabbsson has one of the most full-featured power station apps currently available. And they've been ahead of that curve for at least a couple of years now, I would say. So let's quickly jump into the mobile app and take a look at what I'm talking about. So here on the main dashboard, you can see all of the energy input and output activity, along with other common but important information like the state of charge indicator, the internal temperature, and the remote controls for powering down the unit, or maybe just turning on and off the AC and DC outputs, or even controlling that front-facing LED light. And as I said, that's all pretty common stuff that most power station apps will do. So where it gets actually really interesting is if we open up the settings menu by pressing that little bolt icon in the upper right-hand corner. And here we can see that there's a lot of things that we can get into. So opening up the charge discharge settings, we can pick between 3 charging speeds there, and there's normal, fast, and quiet. Or if you want to get more granularity than that, you can actually press on the charging speed option at the bottom and select anything from as low as 50 watts all the way up to a max of 1500 watts. And that's pretty handy because if, let's say, you're already running a heavy load on a particular wall circuit, well, you probably don't want to plug this thing in and immediately begin discharging at 1500 watts because you're very likely to trip a circuit breaker. Also, when you're not in a huge hurry, you can opt to charge at a much slower rate, which puts significantly less stress on the battery cells and will ultimately help you maintain the most battery capacity possible over time. All right, let's back out of that menu and then let's go take a look at the energy management options. Now, this is something I wish all power station apps would do, but in reality, it seems like only maybe less than 10% or so actually offer this kind of functionality. So with these options, you can actually set the maximum charge limit and the maximum discharge limits. And again, like with charging speeds, setting a max charge limit can help you retain the most capacity over time, especially if you're using this power station in, say, a UPS kind of a situation or use case where you have it plugged into wall power pretty much 24/7, and you're passing that power through your PC or whatever it is that you're wanting to stay powered up without being interrupted in a grid down power outage. Now, if we didn't have the ability to do this, a power station would be forced to basically sit at 100% state of charge all the time. And that puts stress on the battery cells and will have some negative long-term impact on capacity retention, effectively speeding up that natural capacity degradation that pretty much occurs in all battery types. So even by just setting that max charge limit to, say, 90%, you can significantly improve that long-term capacity retention. All right, so I think you get the point there. Let's go ahead and back out of that, and then let's take a look at the time management options. Now, this is a specific feature set that almost no one but Dabbsson has built into their mobile app. Now, this gives you the ability to schedule the power station to turn itself on or turn itself off at specific times. And if we quickly enable the schedule startup option, you can see that you're able to not only define the startup time, but also whether that's going to be a one-off event or something that you want to repeat daily or weekly or on the weekdays or maybe just on the weekends. And that's pretty cool. Now, you can obviously do the same thing for shutdowns, but then there's also the ability to schedule charging and discharging. So let's say that you wanted to ensure that your power station comes back on in the morning around, say, 9 a.m., giving your power station a chance to take advantage of some solar charging, and then so it can begin powering whatever devices you want to power. So what you could do in that particular case is enable the scheduled discharge option and then get in through the menu, press on the AC scheduled discharge option, and then enable a defined schedule there. And you can define multiple schedules with the details of however you want it to behave. So let's say if I'm just on a weekend trip, I could press the weekend tile and then set the startup time to something like, I don't know, 9 a.m. to give solar a chance to wake up in the morning and provide enough charge power to start powering your devices. And then you could set an end time to something like 8:45 a.m. So if it hasn't already powered down overnight, it'll only turn off power for maybe 15 minutes or whatever works for you. But the point is that this type of functionality gives you almost complete control over how this power station will behave, which is super handy. All right, let's back out of that and look at the energy savings mode that I mentioned just a couple of minutes ago. In this section, you can enable or disable the standby timeouts entirely, or you can set the timeouts for either the AC outlets or the DC outputs separately. So if I press on the AC timeout, I can select anywhere from as low as 30 minutes or to 24 hours, or maybe even never, to effectively disable that shutdown timeout altogether. And you have the same options for the DC outputs as well. Now, if you happen to enable the standby mode, it actually uses the default timeout configurations, but it only shuts down the AC and DC outputs when you hit those timeouts, and then it keeps the power station itself in a standby state rather than powering it down entirely, which is handy if you kind of want to be able to jump onto the mobile app and then remote control the unit from time to time. And then, as you can see, you can easily also control the timeout settings for the main display as well. And then backing out once again, you can also use the software in the mobile app to update the firmware from here as well. So like I said, unlike pretty much every other power station on the app market, Dabbsson gives you a level of control over your power station that is pretty much unmatched, with advanced features that are actually practical. All right, to wrap up, let's talk about how this Dabbsson 2000L is priced. Now, the list price as shown on Dabbsson's website is $849, but they've actually been marking that down to an extremely competitive price of $669. And right before I recorded these closing comments, I saw that they're actually running a Halloween sale for a limited time on this 2000L, and it's very temporarily marked down even further to just $583. And I believe that price is good on both the Amazon store and their website. But keep in mind that that $583 price is just for the next couple of days. And after that, I think it probably goes back up to that $669 price, which is still one of the best deals I've seen at about 33 cents per watt hour, especially considering how well built these Dabbsson units are. So yeah, a very solid deal if you're in the market for something with over 2,000 watts of output and over 2,000 watt hours of capacity. And per usual, I will leave links to both their Amazon listing and their direct online store listing if you're thinking about jumping on this deal. All right, so I think that's a wrap. Hopefully you found something in the video useful in some way, and if you did, I'd really appreciate it if you consider clicking that like button down below for me. And while you're down there, maybe consider clicking that subscribe button too if you don't already happen to be a subscriber to the channel. I try to cover a variety of topics in that portable power and solar space, and let's be honest, these kinds of products are expensive, regardless of how competitively priced they actually are. And so I always try to do my best to show you what's working well and what's maybe working not so well, so that you can make more informed purchase decisions with your hard-earned money. Now, I do thank you for spending some of your valuable time with me today, and I hope you'll consider coming back and joining me for the next one. Until then, have fun out there.